free path of a molecule of any gas and again come back to the platform so it can move along y-axis. So how many translatory motions can happen here? My dear students, of each part of the system is the same as the temperature of the surroundings, equally among the degrees of freedom, equal partition of energy happens. Hello students, let us now continue our discussion on kinetic theory of gases, and predominantly to recall the concepts that we learnt in yesterday's session, the postulates of kinetic theory. Very importantly, to understand that the nature of collision between gas molecules is elastic in nature, where I told both kinetic energy and momentum is conserved. We also spoke about relaxation time. We told it is the time taken by a gas molecule to exhibit two successive collisions. And also we spoke about mean free path, which was the average distance traveled by a gas molecule during successive collisions. Now, continuing further, the first thing today, which I already mentioned in yesterday's class, is the order or the magnitude of mean free path of a gas molecule. Any gas molecule is 10 power minus 7 meter. One ankakke tumba important question. The order of mean free path of a molecule of any gas is 10 power minus 7 meter. And the pressure exerted on an ideal gas is given by P equals rho V square max. This symbol is called rho, which basically denotes density. Rho is mass divided by volume, which is the density. And V square max, root mean square velocity. Moving further, a very important concept often asked in the exam, critical discussion, something called as degrees of freedom. Degrees of freedom, a very classical concept that is associated with the gas molecule, what we call as degrees of freedom. What do you mean by the word freedom? Very good. Literally, the word freedom means independence. Please to follow carefully, a bit vague concept. The word freedom literally means independence. Free ಆಗಿರೋದ್ರಂದ್ರೆ ಏನು? ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿರೋದು ಅಂತ ಅರ್ಥ. ಡಿಗ್ರೀಸ್ ಆಫ್ ಫ್ರೀಡಮ್ ಅಂದ್ರೆ ಏನು? We will try to understand the concept of degrees of freedom through this example. I consider a train which is moving along a straight line. A train which is moving on a parallel track in a straight line. Here, it has independence to move only in one axis, in a straight line. So we say it has 1 degree of freedom to move. And you know, if it comes out of the track, what will happen? No definite degrees. So it is moving in a straight line. It is moving on that parallel track. It can move only in one direction. Therefore, I say it has 1 degree of freedom for motion. Second example, x-axis, y-axis, origin. Standing on the origin, I kick a football. It will first travel along y-axis and again come back to the platform. So it can move along y-axis and then along x-axis. Therefore, I say it has 2 degrees of freedom for motion. What about a bird flying in the sky? It has 3 degrees of freedom. So here, with respect to motion, it is the number of independent ways, number of free selected ways in which the object can move. Now, with respect to a gas molecule, what is degrees of freedom? Here we say it is the number of independent ways through which a molecule can store energy. See, very beautiful. When it comes to a gas molecule, it is the number of independent ways through which it can store energy. In the number of ways through which a gas molecule can store its energy is called degrees of freedom. And mathematically, it is calculated as number of translatory motions plus number of rotatory motions. Degrees of freedom is basically calculated as number of translatory motions plus rotatory motions. ಏನಿದು ಕಾನ್ಸೆಪ್ಟು? ಎಲ್ಲೋ ಡೆಫಿನಿಷನ್ ಅಲ್ಲಿ ಸರ್ ಹೇಳಿದ್ರು ನಂಬರ್ ಆಫ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ವೇಸ್ ಥ್ರೂ ವಿಚ್ ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ ಸ್ಟೋರ್ಸ್ ಎನರ್ಜಿ ಅಂತ. ಎಷ್ಟು ವಿಧದಲ್ಲಿ ಒಂದು ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ ಎನರ್ಜಿನ ಸಂಗ್ರಹಿಸಿಟ್ಕೋಬಹುದು, ಅದನ್ನೇ ಡಿಗ್ರೀಸ್ ಆಫ್ ಫ್ರೀಡಮ್ ಅಂತ ಕರೆದ್ರು. ಮ್ಯಾಥಮ್ಯಾಟಿಕಲಿ ಅದನ್ನ ನಂಬರ್ ಆಫ್ ಟ್ರಾನ್ಸ್ಲೇಟರಿ ಮೋಷನ್ಸ್ ಪ್ಲಸ್ rotatory motions ಅಂತ ಕರೆದ್ರು. Then what is it? Very beautiful. Follow here. I will consider a molecule of monoatomic gas. Mono andre single, atomic andre atom. A molecule which has a single atom. Which are those molecules? Helium, argon, all noble gases are monoatomic in nature. Sir, ಏನೇನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾರೆ? Molecule of monoatomic gas. Monoatomic ಅಂದ್ರೆ ಏನು? ಸಿಂಗಲ್ ಆಟಮ್ ಅಂತ ಅರ್ಥ. ಒಂದೇ ಒಂದು ಆಟಮ್ ಇರೋ ಮಾಲಿಕ್ಯೂಲ್ monoatomic, like helium, argon, all noble gases. So ಇಲ್ಲಿ monoatomic gas ಕನ್ಸಿಡರ್ ಮಾಡಿದೆ. Now I fix a coordinate system to this. ಇದನ್ನ x axis ಅಂತ ಕರೆದೆ, ಇದನ್ನ y axis ಅಂತ ಕರೆದೆ, ಇದನ್ನ z axis ಅಂತ ಕರೆದೆ. So how many translatory motions can happen here, my dear students? Translatory means along a straight line. Translatory motion andre along a straight line anta artha, which means a translatory motion can happen along x-axis. Translatory motion can happen along y-axis. A translatory motion can happen along z-axis. So doing, the molecule can store energy along this x-axis. The molecule can store energy along the y-axis, or the molecule can store energy along z-axis. So I say there are 3 translatory motions. How many rotatory motions? The first question is, can this molecule rotate? Why? Nodi, if rotation has to happen, there has to be an axis of rotation. Rotation always happens about an axis, straight line joining the two centers. Illi single atom, axis illa, so this cannot rotate. Please to understand, if the system has to rotate, allond axis of rotation irbeku. What is this axis of rotation? Straight line joining the center of the two atoms. This is a single atom. No axis. Rotation is not possible. So, number of rotatory motions is 0. So what is the degrees of freedom here? 3 plus 0. So please note, any monoatomic molecule has only 3 degrees of freedom because it has 3 translatory motions and 0 rotatory motions. Now, diatomic molecule, di, 2 atoms. ಇಲ್ಲಿ ಒಂದು ಸಿಸ್ಟಮ್ ಬಂತು ನೋಡಿ, 2 ಆಟಮ್ಗಳಿದೆ, hydrogen, nitrogen, etc. Now, 2 atoms. I fix the coordinate axis. Again, x, y, z. How many translatory motions again can happen along x-axis? Again can happen along y-axis. Again can happen along z-axis. So translatory motion 3 idde ide. How many rotations now? Please to understand, the number of rotations is always proportional to the number of atoms present. One axis idd takshana, about that axis both the atoms rotate. So how many ever number of atoms are present, so many rotations are seen. So there are 2 atoms, 2 rotations. Therefore, a diatomic molecule has 5 degrees of freedom. What if it is a triatomic, like water? 3 translatory motions, triatomic ಆಗಿರೋದ್ರಿಂದ 3 atoms, so 3 rotatory motions, so 6 degrees of freedom. So see, very beautifully we are able to calculate the degrees of freedom based on the motion of the molecule. So degrees of freedom is primarily the sum of translatory motions and rotatory motions. Now, a very important theorem which is called the law of equipartition of energy. Again, clinically important for your exam, law of equipartition of energy. The law says total energy of a system. I consider a system, total energy of a system which is in thermal equilibrium. Temperature of each part of the system is the same as the temperature of the surroundings. Thermodynamics allo odidvi. The total energy of a system in thermal equilibrium is distributed among all its degrees of freedom. Law of equipartition of energy. If a system is in thermal equilibrium, then the total energy of the system is distributed equally among all its degrees of freedom. Might have 1, 2, 3, 5 or 6 degrees. The moment there is thermal equilibrium, the total energy is distributed equally among all the degrees of freedom. And the energy associated with each degree of freedom, energy given to each degree of freedom per molecule is half kT. Every degree of freedom per molecule gets an amount of energy E equals half kT, and this is the law of equipartition of energy, where K is called Boltzmann Constant. So what does the law say? The moment a system is in thermal equilibrium, all its energy is distributed equally among the degrees of freedom. Equal partition of energy happens, and every degree of freedom gets an amount of energy E equals half kT. So students, today we understood a classical concept called degrees of freedom, where mathematically it is the number of translatory and rotatory motions, law of equipartition of energy and its consequence. Go through this session, lots of conceptual thoughts. We will meet back in the next session. Until then, thank you.